Hello, Mr. Myasis here, and I want to go over something with you called end behavior. And these are a few more examples on looking at the end behavior of graphs. So if you haven't viewed my previous video, just to really quickly what end behavior is a description of what's happening at the end of the graph. More specifically, what's happening to the y value as x goes out to infinity or as x goes out to negative infinity. So we're looking at the ends of the graph, out here where the arrows are. Sometimes there are no arrows, and we'll look at an example of that too. But one thing to keep in mind when you're doing end behavior is really look for any horizontal asymptotes. If you find any horizontal asymptotes, those are likely going to be your end behavior. If you don't have any horizontal asymptotes, then your end behavior is either going to be infinity, negative infinity, or does not exist. Just think to yourself, what is y approaching? Is y getting closer? Are the y values getting closer to a number, one single number like a horizontal asymptote? Or as x gets larger and larger and larger, is y also getting larger and larger and larger? And that'll kind of lead you down the path of getting the right answer for end behavior. So let's look at three examples, actually four examples of end behavior and graphs. So hopefully you viewed my previous videos on how you describe end behavior. I choose to describe end behavior using a limit notation. And this is the notation that you'd find in a calculus book, so it's important just to get used to it. So the limit as x approaches negative infinity of f of x, and I've written this down on the negative part of this graph. So as this graph goes out to negative infinity, as the x values go out to negative infinity, what do the y values approach? Well, in this example, there is a horizontal asymptote. So we wanted to find that horizontal asymptote, and we noticed that the y value for that horizontal asymptote is 0. So since this horizontal asymptote, as x goes out to negative infinity, that graph is going to get closer and closer and closer and closer and closer to that to the x-axis. So the y values are going to get closer and closer and closer to 0. So our limit as x approaches negative infinity of x is 0. On the other side, excuse me, I'm just going to go get some water real quick. On the other side, we're going as x goes to positive infinity. Now, as x goes out to positive infinity, the y value does the same thing. It gets closer and closer to 0, so this is also going to be 0. Notice that the end behavior here is the horizontal asymptote. The y value approaches 0. So if we locate those horizontal asymptotes, we could pretty much find the answer right away. Here's another example. We have this graph. As x goes to negative infinity, y gets larger. It goes straight up. If y goes straight up, it goes to infinity and beyond. Infinity. We have a horizontal asymptote on this side, so we know as x gets larger and larger and larger, y is going to get closer and closer to 2. So our answer here is 2. Now here is a nice cubic function, and notice that this cubic function does go on forever in the positive y direction and on forever in the negative y direction as x goes to infinity and as x goes to negative infinity. So respectively. So let's look here. As x gets smaller and smaller in the negative direction as it goes to negative infinity, y continues to go down. So we're going to say this is negative infinity. As x goes out to infinity, y also increases without bound. So that's positive infinity. Okay, I didn't have enough room on my board, so I'm going to do a little bit of erasing. So hopefully if you need to copy these down, you pause the video and copy them down. I'm going to do one more example that I think is kind of interesting in our end behavior. So I have a graph that looks like this, and I think this is an interesting graph, and I think hopefully this will describe one more situation that happens with end behavior. So I'm going to start right here with a closed circle, and I'm going to draw a cosine graph, and it's just going to continue in a periodic form. So now as this continues periodically, we have the end behavior limit as x approaches negative infinity of f(x), and the limit as x approaches positive infinity of f(x). So now we have to think about what happens. What happens as x goes out to negative infinity? Well, this graph doesn't go out to negative infinity. It stops right there. Now, if you can't go out to negative infinity, you can't have a limit going out to negative infinity, which means this limit, this end behavior, does not exist. DNE for short, DNE. Now, let's think about what's happening on the other side. This curve, this is a cosine curve, so it's going up and down and up and down and up and down. It's going to 1, down to -1, up to 1, down to -1, up to 1, down to -1, up to 1, down to -1. Keeps going, keeps going, keeps going. As x goes out to infinity, y can't decide what to go to. Can't decide to go to 1 or -1. It just keeps going up and down, up and down, up and down. Can't decide. If you can't decide, then this is another case where our limit does not exist. Because it really has to approach a horizontal asymptote, one number, decide, am I going to approach that number, or am I going to go to infinity, or am I going to go to negative infinity? Those are my only options. If that doesn't happen, it does not exist. All right, so those are 4 examples of end behavior. Hopefully that helped you out in understanding of end behavior. See you next time.